So, Chapter 2 is all about graphing, and so they're going to start out with graphing lines and different ways we might see a line. First of all, if I look at what they call slope-intercept form of a line, it looks like this. Y equals mx plus b. The m is the slope of the line. The b is your y-intercept. So the slope, how slanted your line is, your y-intercept, where does it touch the y-axis? These first ones, you're just going to have ones with the slope so you can see what the slope does to your line. So if I have y equals 3x, what we're basically just doing is making a table, and we're going to put numbers in for x so that we can plot some points on our graph. So we are just going to pick numbers. Usually I pick nice easy ones like 0, 1, and 2. If you want to put some negative ones in there, you can. But just some easy numbers to work with. So when I plug those numbers in, the first one I'm going to take 3 times 0. Well, 3 times 0, just going to give me 0. Then I'm going to do 3 times 1. Well, 3 times 1 is 3. And then I'm going to do 3 times 2. 3 times 2 is 6. I'm then going to plot those 3 points. So 0, 0 should be right in the middle. When I plot the point 1, 3, I'm going 1 in the x direction, so 1 to the right, and 3 in the y direction, so 3 up. So 1 over and 3 up, there's my next dot. And then I'm going to go 2 over and 6 up. When I connect those dots from left to right, on Alex it's going to make you do the ruler so the line's nice and straight. You can see that your line goes uphill because my slope is positive. So my slope is 3 because I ended up going up 3 and over 1. We'll talk about slope later on. But you can tell when you look at that number in front of the x, if it's positive, when you connect your dots, you should be going up from left to right. The second one, we have one that has a negative slope. Y equals negative 5x. So again, we're just going to pick some numbers to put in for x. You want to pick 0, 1, and 2, or do we want to use something else? 0, 1, and 2 sounds good. Those are nice, easy numbers to use. So, if I take negative 5 times 0, I would get 0. Negative 5 times 1 is negative 5. And negative 5 times 2, negative 10, right? So 0, 0 again's right in the middle. 1, negative 5, I'm going to go 1 to the right and down 5. 2, negative 10 would be 2 to the right and down 10. I can't quite fit that one on my graph. Now technically you really only need 2 points to draw your line. If you wanted to, you could then go backwards and put a negative 1 in there instead to get another point. Negative 5 times negative 1 would be positive 5. So negative 1 up 5. Now I have a third dot just to make sure everything lines up. But you can draw it with just 2 dots. They suggest you do 3 just so you make sure everything lines up nice and straight. And you can connect your dots and draw your line. This one had that negative slope. So as I connected my dots from left to right, I went downhill. And anytime you have a negative slope, your line should go down as you go from left to right. Sometimes you will have ones with fractions, like on number 3. So when I'm making my table, I want to be more careful at what values I pick to put in there. I'm going to use 0 because 0 is easy to use. But then what I want to do is use multiples of my denominator because that way I can eliminate the fraction. So my denominator is 3. I would want to use values like 3 and 6 because then they'll come out to nice whole number answers and I won't have fractions that I have to worry about. So starting out with 2/3 times 0. 2/3 times 0 is going to be 0 because we know anything times 0 is 0. If I take 2/3 times 3, the 3's are going to cancel out. I'm just going to get my 2. And if I take 2/3 times 6, 3 goes into 6. 2 times 2 is 4. So 2/3 times 6 gives me an answer of 4. I got nice whole number answers, and then it makes it easier to plot my points. So 0, 0 again's right in the middle. 3, 2, I go over 3 and up 2. 6, 4, I go over 6 and up 1, 2, 3, 4. This one again had a positive slope, so when I connect my dots from left to right, I should be going uphill. I am, and my dots all line up in a nice straight line. So once you do the ones where you just have the slope in front of your x, then you get to the ones that are all the way in slope intercept form, where I have that y equals mx plus b. Again, the number in front of the x is the slope. Tells you which direction your line should go. If I'm going positive, I'm going uphill. Negative, I'm going downhill. The b is your y-intercept. When I make my table and I put 0 in for x, it gets rid of that x term. I would have -3 times 0 plus 3. But that -3 times 0 is just 0, so I just end up getting that n number. That n number is my y-intercept, because if I plot the point 0, 3, I go 0 over up 3, and I'm right on that y line. So when I look at my equation, I know that n number is going to be where I touch my y-axis. Then I'm going to put my other numbers in there, like 1 and 2, whichever ones you want to use. So -3 times 1 plus 3. -3 times 1 is -3. A -3 plus 3 happens to be 0. So over 1 up 0 would be a point. And then if I do the next one, -3 times 2 plus 3. -3 times 2 is -6, and a -6 plus a 3 would be -3. So 2 over, down, 1, 2, 3. My slope was negative, so as I connect my dots, I should be going downhill as I go from left to right, and I am. So if I look at number 5, and I make my table, again, I might just use 0, 1, and 2. If x is 0, what am I going to get for y?
0 or 5.
5. This is going to be 0 plus 5, which is going to give me 5. 5 is my y-intercept. So at 0, 5, I should be touching that y-axis. If I put 1 in for x, -4 times 1 plus 5 gives me an answer of 1. So 1, 1, 1 to the right and up 1. And if I put my 2 in there, -4 times 2 plus 5 gives me an answer of, not 3, but -3, right? Now if I plotted 2, 3, hopefully I would notice and say, oh, look at that, it's not in the right spot. So 2, -3, when I plot that, should line up. And again, this one has a slope that's negative. So when I'm connecting my dots, I know I should be going downhill from left to right. And I am. Number 6, I'm going to change that one quick because all of those have negative slopes. And I'm going to make it +2 instead of -2. So rewrite that one. That way there's just a little bit different example anyway. Didn't notice that when I was typing them. They all look the same. I'm going to make it a little bit different. So again, I'm just going to put 0, 1, and 2 in there. If x is 0, what are we going to get for y? 3. 3 is going to be our y-intercept. We know that by looking at our graph or at our equation anyway. If x is 1, we're going to get
4.
No.
Oh,
5. 2 times 1 is 2, and 2 plus 3 is 5. So 1 over and up 5. And if x is 2, we're going to get 7. 2 times 2 is 4, and 4 plus 3 gives me 7. So over 2 and up 7. We switched the sign, Amy, on number 6, so it was a positive 2 instead of a negative 2, because the other 2 examples all had negative slopes, so I wanted you to have a different looking one. So we changed that one a little bit. And so now we have a positive slope, and you can see here when we connect our dots, we're going uphill as we go from left to right. After you do the ones with integer numbers in front of your x, nice whole numbers, then they're going to throw the fraction ones in there. So on the ones with the fractions, just like on those first ones, when we pick our values for x's, 0 always works nice, and then if you use multiples of the denominator. So in this case, I might want to use 0, 2, and 4. So 1/2 times 0 is just going to be 0. Again, I'm just going to get the plus 3 on the end. We know that's supposed to be our y-intercept anyway. So 0, 3. And then I'm going to put the 2 in there. So 1/2 times 2 plus 3. Here the 2's would cancel. 1 plus 3 would give me 4. So over 2 and up 4. And then if I put the 4 in there, 1/2 times 4 plus 3. 2 goes into 4 2 times. So 1 times 2 is 2. 2 plus 3 is 5. And so 4, 5. Over 4, up 5. And again, you can see that your slope was a positive 1/2, that you're going to go uphill as you connect your dots because your slope is positive. So on number 8, if we are going to graph y equals negative 2/3 x plus 2, thought that beeped. What values would be good to put in for x?
0, 3, and 6.
0, 3, and 6. 0 and then multiples of the denominator so that our fractions cancel out and give us nice whole number answers. So if you take negative 2/3 times 0 plus 2, you get an answer of?
1.
Nope. No. 2. Because negative 2/3 times 0 is just going to give you 0, right? Anything times 0 is 0. 0 plus 2 is 2. So we should get 0, 2, which also is our y-intercept. We know that n number is always going to be where we cross the y-axis. If we do negative 2/3 times 3 plus 2, what are we going to get for our answer there? Nope. 0. 3 goes into 3 once, so I get negative 2 times 1, which is negative 2. A negative 2 plus a 2 gives me 0. So over 3 up 0 happens to be right on the x-axis. And then if you do negative 2/3 times 6 plus 2, you get negative 2. 3 goes into 6 2 times. 2 times negative 2 is negative 4, and negative 4 plus 2 is negative 2. So 6 over, down 2. And then we can connect our dots. We knew that our slope was negative, so as we connect our dots, we should be going downhill from left to right, which we are, so that's always a good sign. And so on number 9, we have y equals negative 1/4 x minus 4. So what values might be good to put in for x?
0, 2,
0 what?
2, and 4.
2 is probably not a very good one because you can't cancel a 2 out with the 4.
Oh. Negative 4.
0, 4, and maybe negative 4. Or you could try 8, depending on if it's getting too big, you might have to go back to the negative numbers. But multiples of 4, so 4 and negative 4 would be good ones to pick. So if I put 0 in for x, negative 1/4 times 0 minus 4, I'm going to get negative 4. Anything times 0 is 0, and so we just get the minus 4 on the end. So 0, negative 4 is my y-intercept. If I put the positive 4 in there, I get negative 5, exactly. Negative 1/4 times 4 minus 4. The 4's are going to cancel out, so I get negative 1 minus 4, which is minus 5. So I go 4 to the right and down 5. 1, 2, 3, 4, 5. There's my dot. And if I put a negative 4 in for x, so here when you cancel, I'm going to say 4 goes into here, negative 1, right? Negative 1 times a negative 1 makes that positive 1. 1 minus 4 then is negative 3. So negative 4, negative 1, 2, 3. And you can see your dots line up, and as you connect them from left to right, we're going downhill. And if you have trouble with the fractions, you can always punch them into your calculator and check and make sure you're getting the right things there, hopefully. Number 10, 11, and 12 say graphing a vertical or horizontal line. When I'm going to get a vertical line always starts x equals, and you just have a number there. You don't have a y value in your equation. When you're going to get a horizontal line, it's always going to start y equals, and you're not going to have an x in your equation. What's really happening is if I make my table and it's telling me that x has to be negative 1, it means in every single one of my points, the x value has to be negative 1. The y values can be anything that you want. It might be 0, it might be 5, it might be negative 2. But what ends up happening when you plot those points, negative 1, 0 would be right there. Negative 1, positive 5 would be right there. Negative 1, negative 2 would be right there. Any point that you plot that has an x value of negative 1 ends up being on a vertical line touching the x-axis at negative 1. So my line just goes straight up and down through the negative 1 if I could draw straight. If I have an equation like y equals 3, it's telling me that for every point on that graph, the y value always has to equal 3. The x values can be anything you want them to be. Might be 0, might be 5, might be negative 2. Hey. So 0, 3 means 0 over up 3. 5, 3, 5 over up 3. Negative 2, 3. 2 to the left and up 3. Notice what happens is you end up with a horizontal line that touches the y-axis at 3, right? Just go straight across right through there. So, if you look at that and you recognize that I have y equals 8, I know that y equals a number always has to end up being what kind of line? Horizontal. I also know where my y-axis equals 8, or my y value of 8 is. It's right there, way up towards the top, right? Since I know it has to be a horizontal line, instead of making a table and plotting a whole bunch of points, I can just say, oh, there has to be a point somewhere here and somewhere here that line up straight across, so then I can connect my dots and draw my line. Unless you want to make a table and plot 3 points, it will work. It gives you the same thing. But if you just recognize, oh, that has to be a horizontal line, here's where y is 8. I know it has to go horizontal, so I put a spot to the left and to the right so I can draw a straight line. There's my line. So vertical ones always are x equals, horizontal will be y equals. And then the next ones, before we get to graphing them, we have to figure out what the x and the y intercepts are. Because when we have an equation that's in what they call standard form, we could rearrange this equation and solve it for y so that we can graph it like we previously did. But we can also just do it by finding the x and the y intercepts. When I do the x and the y intercept, what I'm doing is I'm putting 0 in for y to find the x-intercept, and then the 0 in for the x to find the y-intercept. So if I'm going to find the x-intercept, I'm putting 0 in for y. Negative 6x plus 5 times 0 equals negative 15. Well, when I put 0 in for y, that's just going to eliminate that y term. If negative 6x equals negative 15, when I divide, I've got a negative over a negative, so it's going to be positive, and then I can reduce that down. I can divide those by 3, so I'm going to get 5 over 2. So my x-intercept is 5 halves. And yes, sometimes we're going to get fractions, and if we have to graph a fraction, I'll tell you how to do that in a minute. Once we get down to the graphing ones. My y-intercept. On my y-intercept, I'm putting the 0 in for the x. So negative 6 times 0 plus 5y equals negative 15. Again, when I put 0 in for the x term is going to be gone. So I'm just going to take negative 15 divided by 5. That one comes out nice. I get negative 3. So what I think about here when I do that, I'm finding my x-intercept. I'm just getting rid of the y term from my equation, right? So I get 5x equals 10. If 5x equals 10, then x is going to equal 2. So my x-intercept is just 2. If I'm going to do my y-intercept, I'm getting rid of the x term. So the x term is going to be gone from my equation. So negative 6y is going to equal 10. If negative 6y equals 10, that one I'm going to get a fraction. It's going to be negative. 10/6 will reduce down to 5/3. So negative 5/3 would be my y-intercept. So if I'm going to find my x-intercept on number 15, if I put 0 in for y, what am I going to get for x? I think you put it in for the wrong one. You put 0 in for y. What do you get for x? We get 10 over 7. Right? The y is going to be gone, so we just get 10 over 7. On the other one, and then I write that, 10 over 7. On the y-intercept, when we put 0 in for x, we're going to get 10 over 4, which then simplifies into the 5 over 2. Y equals 5 over 2. So these first ones here, they're going to tell you what the x-intercept and the y-intercepts are and just have you graph the line using just those 2 points. Fairly simple to do. My y-intercept is negative 9, so on my y-axis I have to go all the way down to negative 9, which is way down on the bottom. My x-intercept is negative 2, so on my x-axis I mark where negative 2 is, and just connecting those 2 dots, I can draw my line. Can draw straight. Number 17 then, My y-intercept is -1, my x-intercept is 3. So on my y-axis, I go down to -1. On my x-axis, I'm going to go 3 to the right. Again, they're just going to give you those two dots, but we can draw a line just by connecting those two dots. And so there I have my line. So on number 17, this one says the x-intercept is 4, so they gave us our x-intercept first, putting 4 on my x-axis. My y-intercept is -3, so down to -3, and then again I can connect my dots and draw my line. So then they get to the ones where you're graphing those ones in standard form. They are going to have you have a box that tells you what is the x-intercept and what is the y-intercept. Then they're going to have you put it on the graph. So my x-intercept is when y is 0. If I put 0 in for y, gets rid of the y term. -6 divided by 3 gives me -2. So my x-intercept is -2. I can put that on my graph. My y-intercept is when x is 0. So I get rid of the x term. Then I have -6 divided by +2, which gives me -3. So my y-intercept is -3. I now have my two dots. I can connect my dots and draw my line. Now number 19, there's one where we have a fraction where we have to use a different tool to get it in there. First of all, if I find my x and my y-intercepts, my x-intercept, y is 0. So if I put 0 in for y, I'm going to get what for x? -5/2. On this one, you have to use a little tool over to the side that looks something sort of like this. When you click on that, it'll say plot a point anywhere. When you type it in, you have to type it in as the ordered pair. So you're going to type in -5/2 for the x box, 0 in for the y box, and that's going to plot your point. That point's at -2.5, so we'll just estimate where that is, partway between the -2 and -3. But on Alex, you'll use that plot point anywhere.
Do you have different problems than I have?
I do not know. Do you have different problems than you have?
19 and 20 on this page.
Oh, I might have spaced it out a little bit more. You have 19 and 20? Oh, there's no 18. Where's 18 at? 18 was the same. 19 is that one. I don't know where the numbering went, crazy.
Okay. Okay.
I'm not sure why the numbering is off. We did 3 of each kind, so that should be the right numbering, but your numbering has weird numbers. I do not know. They're the same problems though, right? Just a different number. So if we do the y-intercept on that one, if we put 0 in for x, we're going to get what for y?
1.
+1, because we'd have -5 over -5. So we get +1 for our y-intercept. You could use the plot point tool and type it in, but since it's a nice whole number, it's probably easier just take the pencil and click on the +1. And then again, you have to take your ruler tool and connect those two dots in order to draw your line. But if you do get a fraction, then you've got to use that plot point tool, and it'll put it on there for you. And the last one, which yours says 21, but mine says 20. I don't know. Yeah, that numbering is off somewhere. I got to check that. Is one where they have it not quite in standard form yet. They have 3x plus 2y minus 8 equals 0. If it's like this, the first thing you want to do is go ahead and move your number to the other side. So I'm going to rewrite this as 3x plus 2y equals, and since this was a minus 8 when I move it over, it's going to make it a positive 8. Now it's in standard form and I can find my x and my y-intercept. So for my x-intercept, Y is 0. If I get rid of the y term, x is going to equal 8/3. And again, that's one you'd have to let the computer plot. You would type in 8/3 with 0. Let's see, that'd be about 2 2/3, so not quite to the 3 if we just estimate where it is. On Alex, the computer will put it exactly where it belongs. My y-intercept, when x is 0, I'm going to get 4. 8/2, which is 4. So my y-intercept, that one's easy to plot. It's a nice whole number. I can just click right on the 4. Then I can connect my 2 dots and draw my line. Alrighty. Let's see what the word did. Change my numbering.
You probably forgot a number.
I forgot a number? That could be. I don't know why it changed it from the time I printed it to when I just brought it up, but hey.